The broadcast is now starting. All attendees are in listen-only mode.
Okay, Sean.
Hello, everyone. My name is Sean Mullen. I am a NOAA Sea Grant Knaus Fellow working in the office of Congressman John Garamendi, and I'll serve as your MC today. I want to welcome you to the NOAA Environmental Leadership Seminar Series. The overarching goal of these agency-wide seminars is to showcase insight and examples of the environmental leadership role that NOAA plays in our society by featuring NOAA's leaders and subject matter experts critical to carrying out its mission. I'd like to take a moment for a few acknowledgements and webinar details. First, I'd like to thank the NOAA Science Council for sponsoring these agency-wide seminars and the NOAA Seminar Leadership Team that organizes them. That's Tracy Gill with NOS, Sandra Klar with NESDIS, Katie Rowley with OAR, Lindsay Kratz with NIMS, and Hernan Garcia with NESDIS. Second, I'd like to share some seminar logistics. All online attendees are muted. You may type all of your questions and comments into the GoToWebinar question box at any time, and we will address as many as we can at the end of the seminar. And we are recording the seminar for later viewing. Today's NOAA Leadership Seminar is titled Top 10 Gotchas, an opportunity to improve NOAA NWS impact-based decision support services. And our speaker is Kenneth Graham. He is the director of the National Hurricane Center at NOAA's National Weather Service. Ken began his career with NOAA in 1994 as an intern forecaster at the NOAA National Weather Service in New Orleans. His career took him to the agency's Southern Region headquarters in Fort Worth, Texas, as the Marine and Public Program Manager during National Weather Service modernization in the early 1990s. He became the meteorologist in charge at NWS forecast offices in Corpus Christi, Texas, and Birmingham, Alabama, where the offices were awarded a Department of Commerce medal each year from 2001 to 2005 for innovative services, such as instant messaging with television stations during critical events such as the Veterans Day tornado outbreak. He has served as Systems Operations Chief at Southern Region Headquarters, where he won a bronze medal for leading a team to make critical repairs in New Orleans following Hurricane Katrina. He then moved to Washington, D.C. to be Chief of Meteorological Services, where he worked closely with partners to improve services and brief congressional committees. He served as the meteorologist in charge at the NWS New Orleans and Baton Rouge office, during which time the office won the Department of Commerce Bronze Medal for innovative services during Hurricanes Gustav and Ike, the National Weather Association's Operational Meteorology Award, and was included in the Department of Commerce Gold Medal Award for Decision Support Service that was presented to NOAA for the Deepwater Horizon oil spill. Ken received the National Weather Museum's Weather Hero Award for 2010. Ken has extensive experience working directly with emergency managers during numerous high-impact events, including nearly 2 decades along the U.S. coast. He has deployed to emergency operations centers, provided impact-based decision support briefings for emergency managers and elected officials, and delivered numerous training sessions and exercises related to tropical weather. Ken was elected a board member of the Louisiana Emergency Preparedness Association, is a member of the National Weather Association and the American Meteorological Society, and is a licensed ham radio operator. He is also the chair of the World Meteorological Organization for Regional Area 4, North and Central America. More recently, Ken is one of the finalists in the 2021 Service to America Medal for Safety, Security, and International Affairs. Welcome, Ken. Thank you so much for your leadership and for being here. I'll turn the mic over to you.
Okay, thank you so much for that introduction, and thank you everyone for the invitation today to speak. This is a great honor to be able to talk to everybody, especially this presentation that's pretty much different. It's a different type of presentation than we normally give, and it was talking about you could talk about the science, you can talk about the service, but this one really combines the two and talks about how the science drives the impact-based decision support services. As I say, IDSS, that's really that taking that science and taking the communication and delivering that so our partners across NOAA can make those really tough decisions. So that's what that IDSS is. So this is the top 10 gotchas. It really is a culmination of 27 years in the Weather Service and NOAA, and seeing on the ground what can go wrong, what are the challenges when it comes to that communication, the delivery, and the decision-making process on the ground. So capturing that over the years, and even some of these very recent, over the last couple of hurricane seasons, that's the real impact-based decision support services. Most people have the forecast already. So what do you deliver? It's what they don't have. It's the things that could go wrong. It's really having that relationship with their partners to be able to understand them enough to be able to deliver a service that they can really have. So if you think about the top 10 gotchas, it begins with, well, you got to have partnerships. It's a little cliche, but it's important because these partnerships are everything. And some of the pictures that you see here, we take so serious here at the Hurricane Center. And I know across NOAA, we work with all of our partners, but having them in the building, it's been tougher with COVID. So we've tried to do it as much as we can remotely, but having the emergency managers in the building to meet everybody. And even today, we have NAC staff here in the building listening to the presentation, but bringing emergency managers in, running them through exercises, going to their location, doing exercises, and really spending time on our products, how to interpret those products, and how to equate those to decisions. You can see some of these relationships building here, and it's so important. This is something that I always like to say. We talk it around the Hurricane Center all the time. Those connections, connect's a verb. You got to go get those relationships. You have to spend time with our partners to fully understand what their issues are, the problems, and it's unique depending on the location. Every parish or county, state across the country, and internationally as well. We're responsible for 28 countries. We do the forecast for 28 countries, and those countries issue those watches and warnings. But having those relationships to be really fully engaged with those issues, that's where the IDSS comes into play. And that's why looking at what could go wrong is a good place to be when you're trying to talk about the latest storm and the latest forecast, and get that information to them so they can make those tough decisions. So there's just some examples around the table, just all the different things that we do on a normal basis. It's going on all over the country. I think it's just important that we realize connect's a verb. You can't sit back in the office. You really got to go out and get these relationships. Here's some other examples here at the Hurricane Center with some of the folks involved, and definitely a challenge, right? I mean, being so out there in all the outreach events, and now, thinking about a situation that we had to figure out how to do it all virtually, and we did. Hurricanes at home, really getting information out to schools, really turning this connect into a virtual connect, and hopefully with time get back out there to do much more of it in person. So that's just an incredible, really important piece of this. And connect, it builds trust. When you know the partners at a much higher level, a deeper level than just meeting them, it's attending their exercises, it's building that trust. And I have an example that's not hurricane, but if you allow me, I'll tell a quick tornado story. This was back in Louisiana as the meteorologist in charge at the New Orleans office, and it was a big tornado event expected, and communicating that to the emergency managers. That's a typical thing we do as part of IDSS, but this one was different. This had all the parameters for a much bigger event, and this actually was the event, the tornado that hit the National Finance Center, where we all get our paychecks, by the way. That's what the tornado got it on this day. But it was interesting that the trust was there, the relationships were there. There was communication with one of the parishes, and this emergency manager is now retired, and we shared this story, and we just reflected on it, and we were about to put out the tornado warning. We really saw it on the radar. It was a serious situation, and I got my cell phone and I called him. His name is Dexter. I said, Dex, Ken, you're about to get your butt kicked. That's it. He says, thank you. Click, we're off the phone. It wasn't until later I found out what happened, because we've already had the connection and the trust. They had a member of the school board in the EOC, and based on that very short phone call, they got on the walkie-talkie, and within less than 5 minutes, there were about 10,000 kids in the hallways of those schools to get ready for that tornado. That's what I'm talking about. It's a level of connection that's coworkers almost. They're partners, but they're coworkers with us, and that's what really builds the trust. Connect's a verb across NOAA as well. So many people signed up around NOAA. We got to do better. We got to do more with each other as well. And it's also not just there's projects we work on, but there's such an opportunity to really be eyeball to eyeball in the heat of the battle as well across NOAA. And I was just trying to think of some of the different things. It's with science. It's looking at everything from working on papers together, being in the same place during big events. It's test beds. It's all these opportunities that we can use to bring it together. The science, the observations, it's the service. And I really like this one's the most important to me. And people that know me, it's the people part of it. And you really getting this job 3.5 years ago just really allowed me to see NOAA in a different way. Everybody coming together for these big events. And I really wanted to spend just 10, 15 seconds on this. I hope everybody listening, whether it's the weather enterprise or across NOAA, it's so important to realize everybody's a big part of these big events, whether it's a hurricane, tornado, fire, flood, space event, coastal flooding, whatever it may be, or a mariner on the ocean getting information to protect their crew and their vessel. Everybody's a big part of that. And I just really wanted to spend a couple minutes talking about that. And together we're so strong. And I think it was important to be able to do that. Why does it matter? I talked about trust. I talked about how we got to come together across NOAA. Why does it matter? This is why it matters. Those decisions are tough. So I want everyone to take your shoes off, not literally. Take your shoes off, put the shoes on of an emergency manager. These are the tough decisions. I have to evacuate 3 million people or not. What shelter should we open? Is that shelter safe? I have to evacuate a 5,000 member prison. Where am I going to put those folks? When should I start contraflow? In other words, all the interstates go in the opposite direction. I've got oil rigs. When are the seas and the winds too high where I can't evacuate all sorts of workers over the waters, get them out of harm's way? Where do I put supplies that they're not underwater, but they can also get in really quickly because people are hurting? Food, medicine, tarps, generators. Where do I put the swift water teams? When do I activate the contract to feed all the people in the EOC? These are all real things. Activate bus contracts to help those that can't get out. The underserved population, the ones that don't have cars, the ones that can't afford to leave. And that's a lot of people, can't afford to leave. So there's programs to help out with that. When do you start those? Charitable organizations, where do those go? Gates, think about levees. You think about all the things to keep the water out. All those decisions have to be made. People with special needs, how do you evacuate? And when do you evacuate? Should you evacuate a hospital where there's critical patients in that hospital? And you know darn well that decision means some of them may not make it. These are tough decisions. It's so important no matter where you sit in the enterprise, no matter where you sit within NOAA, Weather Service, NOS, NESDIS, OAR, it all comes together in these big events. That's where it comes together. These are tough decisions, and it's our responsibility to take the science, all the science, the exercises and the practice, and turn that into products and services to help do this. This is what saves lives. It's been busy. We've had a lot of opportunity to reflect, to think about what we're doing, right? To think about how we're doing it, how could we get better? It's been so busy. Some of these statistics here. We've had more United States landfalling Cat 4 and Cat 5 hurricanes since 2017 than we have from 1963 to 2016. It's incredible. The United States has experienced 19 named storm landfalls in 17 months, 11 in 2020 and 8 so far in 2021. I think we're looking around. I think hopefully we're okay for the rest of this season. But look at these maps. It's just a staggering. Here's a little clear. Think about this: 16 hurricanes have made landfall in the United States since 2017. Look at this map. We've been beat up. It's been busy, not just for across NOAA, but the enterprise, the media, the emergency managers, and we've had to put COVID on top of this, right? 7 of those were major. Those are the numbers through 2021. I've got 2020 data here for the damage. There's $353 billion worth of damage, and that's as of 2020. We haven't put Ida in there. We haven't put the storms in yet for 2021. Staggering. It's been that busy. So here's the gotchas. This is using science to focus on what the message is. Our partners, the decision makers, they probably already have the forecast. So you want to brief on what's changed in that forecast. But the biggest thing is to focus on things that's really going to get them, the gotchas. And here's the top 10 gotchas. It's an opportunity to look at what could go wrong in the decision-making process and the science to really help drive and improve that impact-based decision support services. That's what they're looking for, the things that are really going to save lives. And I think this will make some of it clear. One, top 10 gotchas. Number one, hurricanes really, they don't care about your timeline. We've got some storms that can give you a week's notice. We got other storms that may only give you a few days notice. And it was interesting that we looked into the data. And by the way, this whole presentation, this is only, we gave part of this at the International Association of Emergency Managers. And a couple of these slides got a lot of attention with some of the emergency managers. And we're going to continue to have some of these conversations. But look at the data. This is what I'm talking about, looking at science to really drive the messaging. Out of the nation's strongest storms, I'm talking Category 5 hurricanes, we've had 4 make landfall in the United States. Every one of those was a tropical storm just 3 days prior. They're short notice, they're fast. The Labor Day storm, 1935, Camille, 1969, Andrew, 1992, Michael, 2018. But it's interesting perception when you talk to the public, you talk to people and they think about these big hurricanes, they think about these tracks going all the way across the Atlantic. They think about, looking around the room, right? It just seems like these long tracks, right? It's not the case. So we dug deeper. Let's look at every storm, 150 miles per hour or greater over history. All but one was a tropical storm 3 days before landfall. All but one is a short fused event. It's interesting, looking at everything we got, 150 miles per hour greater on record, only one of those really gave a whole lot of notice. That's something we got to talk about. So look at some of the data on this slide. It kind of sums it up. And the big thing is the red sentence at the bottom. If you look at the last 100 years, all of the 150 mile per hour or greater hurricanes in the last 100 years, they were tropical storms or less 3 days before landfall. Here's the issue. Here's where it equates to service. Our plans, whether it's evacuation, whether it's what we have to do. Remember I talked about those tough decisions on the bubble slide. There's 5-day plans, there's 7-day plans. And during Deepwater Horizon, I saw a 14-day plan preparing for tropical activity. But the reality is as a nation, we have to work on some 3-day plans to make sure we have them just in case, because of this. Only 3 of those strongest storms became tropical depressions 5 days prior to landfall. 3 days prior to landfall, only one of them was a hurricane. The average time of those 9 storms becoming a hurricane was 50 hours before landfall. Of the 4 Category 5 hurricanes to strike the US, once again to repeat, were tropical storms 3 days prior. So we really need to focus the messaging shorter. We need 3-day plans, and we're working on it. We're having those conversations with our partners, the states, the counties and parishes, and the nation to start thinking about we better have some plans that are shorter. That's what I'm talking about in this presentation, using that science to drive the messaging. Here's the other part. In 2020, 9 Atlantic tropical cyclones underwent rapid intensification, several just before landfall. In other words, short notice. Not just the development part of it, but deepening, strengthening rapidly right before making landfall. And what that does, that compresses that timeline. So that's a serious thing that we always want to talk about. Number 2, little wiggles matter. So what am I talking about here? This is, again, using science to talk about how we can talk about in storm surge in this case. The purple line in the middle, that's the track of Hurricane Laura. To the west of it, to the left of it, there's a dotted blue line there. That's hypothetically if we moved Hurricane Laura 20 miles to the west. On the map, displayed on the map is the colors. That's the delta, the change in storm surge associated with that 20-mile wiggle, right? It's just a wiggle or a wobble. 20 miles difference. In this case, if you look at the colors, in some areas in Louisiana, 10 to 15 feet higher storm surge. In Lake Charles, 5 to 10 feet higher. 20 miles, a little wiggle or wobble to make the difference in a 10 to 15 foot storm surge. That's how we have to communicate. And that's why we spend so much time here looking at how to portray information in a probabilistic fashion. If you have only one track 2 days out, I can't tell you within 20 miles where that's going to go. Little wiggle or wobble, different direction, you got a whole different solution. The goal here is to get people out of harm's way. They got to evacuate. We're saving lives. So as a result, we run 400 or 500 different solutions, and you come up with information that gets people out of harm's way, because a couple days prior, who knows where that little wiggle is going to go. Okay. Now, interesting. This is brand new. This is brand new information that I want to show here. This is IDA. We've always, the little wiggles matter. It's interesting when we do our presentations, it's usually associated with water, which is good. It's true. But there's also a wind component here. This happened in Hurricane Ida. This is the forecast, a 24-hour forecast. You can see up there, really getting up there in portions of just north of Baton Rouge. If you look at the map, that's where the hurricane was forecast to be 24 hours out. Go along the track back towards the Gulf. That's our forecast 12 hours out. Not bad. I'm going to go to the next slide. This is what actually happened. The actual position. I'm going to do the optometrist thing here, better, worse, go back and forth. The 12-hour position didn't change much. Didn't change much, but the system slowed down a little bit. It slowed down a little bit, started wobbling, very typical of a strong storm. That's not much change. 20, 30 miles, again, back and forth. That's not much change. But what interesting that happened was it's well understood that the center could move back and forth, wiggle and wobble, but it was more difficult to conceptualize that the winds go with it. The wind radii moves too. Does that make sense? So I don't want to try to do this with my hands. I think you can see. So there was a problem in Ida that you could wiggle the center, but it was conceptually more difficult to see the winds move. They move together, right? So that's something that we learn. That's something that we can communicate through this IDSS. Again, this is science. This is something real. This is what happened, and something that we can look at to the future. Little wiggles matter, even the structure. Two hurricanes. Look, same track. If you look at the line there, the track, both of these are the same track, but the one on the right is a stronger storm, but smaller. Look at the difference in storm surge. 2, 3, 4 days out, it's going to be very, very difficult to fully understand what that structure is going to look like. That's why we spend so much time with the hurricane hunters. They do such an amazing job really looking at that structure. It's not just the center. What's the structure look like? Is it a big storm, small storm? All that matters. And that's all in our forecast, and something very, very important when it comes to storm surge. That storm gets a little smaller, even if it gets stronger, completely changes the outlook when it comes to that storm surge. That's why we do it probabilistically. Number three gotcha. Every storm is so different. It's a little bit of a cliche when we say that, but there's science behind it. They're all different. As the initial intensity of a storm increases, our average track error actually gets smaller. In other words, if it's a developing storm, just starting to develop, our errors are higher. If it's a storm that's jumping around, if we get data from the hurricane hunters that show 3 different centers, doesn't seem like too big of a deal, right? It is, because if the center moves 10 miles, that could be a 40 or 50 mile change in 2 days along the coastline. It matters. So we have to communicate in our IDSS. There's also a confidence portion of that, sharing the information of this one's developing, it's changing, it's rapid eye wall changes that are happening, and that could change the forecast rather quickly. So this is using history, using the verification, which we constantly share, is very openly shared with the public. This is something that we share with the emergency managers, and it's an important one, the confidence part of it. This is, you just share it. Tell them it's jumping around. You better pay attention to the cone, and that's a case where it could be anywhere inside that cone. And the definition of the cone is based on the average error over the last 5 years, where we think that center will be 2/3 of the time. That means 1/3 of the time it could jump outside that center. That type of information is critical to the emergency managers making these decisions. If you look at this, this is a a great example of the differences. Laura, look how consistent. By the way, those lines are our forecasts. Look at Laura, just very consistent. Emergency managers, our decision makers, really need that consistency, because if we're bouncing all over the place, that's tough to make decisions. And actually, the social science shows that bouncing all over could lead to delays in some of the decision making. Laura, consistent. Marco, all over the place. Sally is the one I was referencing that had 2 to 3 centers at different times. And look at the variety of the forecast. Most of that inside the cone, but at the same time, really tougher to really pinpoint exactly where the storm's going to go. That's valuable information, because you can tell all those folks there could be some wide variety in where it's going to go. This is brand new as well. I wanted to share with you. This is IDA. The line on the right is IDA's track. Interesting enough, if you go back to the day before the first advisory, so the first advisory was on a Thursday. If you go back to the model guidance, if we would have put out a forecast the day before, that left line is where it would have gone. That's where it would have gone. And if you think about that, it's interesting. With also social science talks about something called anchoring, and there's a huge tendency to anchor on that first piece of information. And having that social science, having that background, knowing that, really careful about that very first forecast. We take that first forecast very serious, because people do anchor on that. Why is that forecast would have been so far to the west? Because that's where the model guidance was on Wednesday. On Tuesday, this goes back to the trust. This goes back to the relationship. First forecast came out on a Thursday. I made phone calls on Tuesday, state of Texas, to FEMA, to state of Louisiana. And the conversation was, not really sure where it's going to go, but the models are very consistent that this is going to be strong. Somebody is going to get impacted, huge, historically impacted. Texas started doing some things. Louisiana started doing some things. FEMA started doing some things, even before our first forecast, because we already had those relationships, but we weren't confident enough to get that forecast out yet. This is where the models concentrated by the time we got to Thursday and we got to work, right? We got that forecast out and made sure Southeast Louisiana was really ready. Look at that, the forecast, what it would have been on the left, and all of our forecasts. Every different forecast is plotted there in blue. Pretty consistent. You can bank on that. And it's not just the track. This is a kind of a depiction of the intensity forecast. Look how consistent as well. You get into the reds and the purple there. We talk about it here. Probably one of the boldest forecasts in National Hurricane Center history, to go to a major hurricane on that first forecast. And talking to some previous directors, I said that never used to happen. But we have the science, we have the modeling, we have the observations. We've all worked so hard to improve what we do. We have the confidence to do this. I think it's a marvelous example of how far we've come. But look how consistent even the intensity forecast was. You don't normally see that like that. That's pretty impressive. Number 4. The number 4 gotcha. We have to have many more conversations in our agency about indirect fatalities. We've got storm surge watches and warnings. We've got products and services. We're doing this IDSS. We're doing a great job reducing the direct fatalities in these tropical systems. We're still losing a lot of people from indirect fatalities. It's the underserved communities. It's your elderly. Here's a case. This is real data. You're 8 times as likely to be a victim of a tropical system if you're over 60 as if you're under 21 years old. There we go. Using science, using data to be able to help us focus that message to the people that are actually losing their lives. And I had a great conversation yesterday with the state director in Virginia, talking about how to better get our communication and better get our data and warnings and information to underserved populations as well. So we still have so much work to do. But look, this is indirect. This is brand new stuff I want to show you. This is from this year. I don't think I've shown this anywhere yet. IDA, direct versus indirect fatalities. This first slide is the direct fatalities we had from Hurricane Ida. 4 direct fatalities in Louisiana from a Cat 4, almost a Cat 5 hurricane. What was it, Cody? 12, 14 feet of storm surge in some of these areas. You go back a few decades, it's hard to fathom how many would have lost their lives in this storm. It's 4 too many. Look at the direct fatalities. We have 47 in the Northeast U.S. And we've had some wind, we have storm surge and tornado in Louisiana, but look at the ones that we had in the Northeast U.S. Mostly those associated with tornado, but most of them flooding. I think it's, we talk about that. That's nothing historically. It's happened before. You go back to Hurricane Camille in 1969, Category 5 hitting the Mississippi coast, and the greatest fatalities were also inland, Virginia. Some of the huge flooding that took place back in 1969 from that storm. But watch this. So 4 direct Southeast Louisiana, 47 in the Northeast. Let's put indirect on here. It flip-flops. 26 indirect fatalities in Louisiana, 4 indirect fatalities elsewhere in the United States. We had 13 heat and 6 from carbon monoxide poisoning. The Weather Service was doing an incredible job. We had the media, everybody was trying to cover generator use, proper use of generators. And that number, I think, would have been double, if not triple, if we didn't really push this hard across the country. And I think it made a difference, but it's still 6 too many. And some of the conversations that I've had with some of those folks, the number one reason that some of these generators were in the wrong place was they were afraid people were going to steal their generator. Let's deal with it. Let's deal with it. How do we educate people on how to keep their generators from being stolen? Maybe that'll help reduce that number. So you can look at the data. I don't have to go through all of it here, but with Hurricane Laura, we had no storm surge fatalities despite a 15 to 20 foot storm surge. 7 direct fatalities, wind 5, 2 rip current, 34 indirect fatalities from Hurricane Laura last year, 16 of those carbon monoxide. So we have to have these conversations. We have to keep talking about it. You can see the preliminary from IDA. You can see some of the data there, but I want to focus on the bottom sentence, the big font. Historically, storm surge, 50% of fatalities. The leading cause of fatalities in these tropical systems. We've tried to tackle that. We've tried to tackle it with watches and warnings, inundation mapping, communication. I think we're making a difference. In the last 4 years, we've lost more people to carbon monoxide poisoning after the storm than we have in storm surge. That points to where we need to focus. The next one, number 5. The number 5 gotcha, so to speak, deterministic concerns. Hurricane Laura. Let's go through this, and then I'll talk about a little story. Hurricane Laura guidance. This is 18Z, August 24th. That's where all the guidance said Hurricane Laura was going to go. So we feel good, right? There's some consistency there. We have our forecast. The whole focus is basically Southwest Louisiana. I mean, the whole conversation is about Louisiana. Watch what happens. With time, this is 0Z, August 25th. We're progressing. We're getting closer to landfall. Not too different, but look at those outliers on the left. A couple more outliers pointing to some solutions further to the west. Why does that matter? Houston. If you think about you're in Houston with, remember the bubble chart, all the decisions you have to make, the focus is on Southwest Louisiana. Now you're starting to see some lines get closer to Houston. Now you're starting to worry, and especially by 06Z on August 25th. Look how the models start to really focus further to the west. The line, the white line there on the right, that's our forecast. Look how those models started shifting. How many phone calls with Houston? I look around. They were calling constantly. We were constantly talking to them, just saying, hey, stick to our forecast. We're good. We're seeing some of this. We think it's temporary, and our forecast did pan out, but that's tough. So what happens is everyone's got access to the models. It's a good thing. Everybody's looking at these tracks. Frequently during a hurricane, we will get calls. I will get calls. Ken, did you see what this model's doing? Everybody's watching these lines. The issue is, that's fine, right? The issue is people pick their favorite line a lot of times based on their personality type, and the public's doing it too. So you have a situation that you have people that they lean towards a little more of the doom and gloom. They're going to pick that line no matter what, even if it's persistence, even if it has nothing to do with the situation. They're going to find the one line that gets them. Others will see the lines further away and delay or not make decisions or the wrong decision based on that other model. People will search, they'll shop for the solution that they want. That's where that comes into play. Okay, and that's why we're really trying to push towards, I talked about the probabilistic and the storm surge, and what we do is a 10% exceedance. And everybody watching that gives briefings on impact-based decision support services, one of the most frequent questions you get is, how bad could it get? Ken, what's a worst case scenario? Everybody gets that. The problem is, as a meteorologist, as a scientist, any discipline, you can come up with some terrible worst case scenarios, including the moon leaving orbit, right? You can come up with all sorts of bad things, but a 10% exceedance is a reasonable worst case scenario. Another way to put it is, there's only a 10% chance of that value getting higher than that. You can bank on that. As a decision maker, I'd take that. We're going to work on doing that for wind. We're going to work on doing that for some of our other parameters as well, because people can use it. Look at the improvement over the years. The forecast from the National Hurricane Center has a lower average track error and more consistent than any individual model. We're making a difference. We're blending them. We're looking at them. And you can see the graph here. What we can do now in 5 days, really dreamed about doing out to 2-3 days if you go back decades. It's amazing how far we've come through everything from testing things, science, test beds, coming together, getting observations are so critical. I gave a presentation to the World Meteorological Organization yesterday, and I went through a historical look at observations and how history says big leaps in observations led to big leaps in service because it improved the forecast, it improved modeling, and in the end, that drives the service and saves lives. And this is just an example of that. Also, a model may do good on one storm and the next one not so good. They're getting better. But following one, especially the public, could really lead to decisions that we may or may not want to have. Bottom line is the official forecast from the Hurricane Center. We're beaten in the individual model. And if we start looking at going to that 10% exceedance and really looking at ways to portray things probabilistically in worst case, I think it's going to be even better for the decision makers. I did want to put something in here, basically trying to talk about probabilistic. This is an important point. This is the tough conversation. A lot of these gotchas are the tough conversations that we have to have. The excessive rain outlook, the Weather Prediction Center, amazing. They do such a great job with this. It's so critical in these big rain events, a hurricane or any time, that this product is so spectacular. It basically shows where's the greatest area of rain-induced flooding. Where are the problem areas? It's a situational awareness tool. It's not a forecast for a specific location. It says if you're in that red or pink area, you better be ready. That's what this says. However, it's a situation that if the Storm Prediction Center also does a great job, if they come out with a moderate or high risk of a tornado event, I've worked these events at the weather forecast office many years. Moderate or high risk of a tornado, you close schools, you activate EOCs, you're getting people off the road, you're shutting things down. However, when we have a moderate or high risk of excessive rainfall, that often could kill more people than the other, we don't have the same response. So we have to talk about, let's have this hard conversation. Let's talk about why. Let's talk about educating. And this is staggering. This is the education that we have to portray in our exercises when we talk to decision makers. They're a big deal. A high risk from the Weather Prediction Center is a big, big deal. In fact, it's 2/5 of all flood-related fatalities. It's 9/10 of all flood-related damages. So we have to figure out ways to portray probabilistic information where the decision maker almost interprets it as deterministic so they can make a decision, if that makes sense, because it helps them. It helps to portray the confidence. But this is just an example of what we can do and what we need to get out there. Number 6, the 6 gotcha. I'm going to try this. My time goes fast. Forecast accuracy, better decisions. We're looking at like 50 solutions. We're blending those together. Right? We're blending these together. You have all sorts of situations out there where you're looking at so many different models, and we kind of covered this already, but this is what we didn't cover. This is important. Again, why does it matter to really focus on that official forecast? On the left, that's a forecast tracks from Hurricane Floyd, 1999. At the time, the largest evacuation in US history at the time, 2.6 million people. On the right, Hurricane Dorian, improvements, confidence, relationships, trust. As many as 3 million people did not evacuate, right? It didn't mean we didn't, lost about 3 days of sleep on that one, making sure we're going to turn here, but that's the confidence level, that's the trust. The uncertainty in 1990, that's the cone. Go back to 1990, that's the size of the cone. Today it's that. That helps. That's why the science matters. That's why the observations matter. That's why everything we do has to be about operations, because we're saving lives. It all comes together in the end to get a decision, to get an action. The public, emergency managers, anybody, and having us all on one page leads to better decisions. That's staggering. That's why we do what we do. Words matter. Gotcha 7 really matters. Remember, we've made a difference in the fatalities with storm surge. 15 to 20 feet above ground. Well, it's pretty bad. But the problem is, I find myself so many times trying to equate. I'm 6'5", so I'm trying to say 6'5". That's 3 of me. Trying to portray what that really means. And if you look at numbers, it's hard to say until you equate it to something what the public, how they really interpret those values. Okay, storm surge warning, that's bad. But again, we get other warnings, other things happen. I don't know what I should respond to. In Hurricane Laura, we still had people not evacuating with a 15 to 20 foot storm surge forecast. So putting our heads together, talking to the folks in Louisiana who came up with the name unsurvivable, the word went viral. Went viral. Finding a way to get people out of harm's way. We were flat out told, because of that word, we got the stragglers out and there were no storm surge fatalities. 100% evacuation rate. 8, no such thing as JUSTA. As the chairperson of the WMO Region 4 Hurricane Committee, where we come up with the names, we retire the names, and all of that, I will make sure there's never a Hurricane JUSTA. And why? Because whether it's a Category 5 or a Category 1, it's still a big impact. In the United States, between 2010 and 2020, Category 1 hurricanes have caused 185 direct deaths and $110 billion worth of damage. Right? It's not about those categories, it's about those impacts. There'll never be a Hurricane JUSTA. It's all about the impacts. If you look at our products, we got 9 social science projects that we've had going on. We're going to get all that data, and we're going to try to put this into this room here, this test bed, where we could bring universities and talk about how do these products improve? How are we going to improve these products with all that data? It's all about the impacts. We talk about the wind. We talk about the surge. We base it on in the order of fatalities, right? We try to base it on the science. We talk about the tornadoes. We talk about the actual flooding, inland rain. We have to tackle that as well. 25% of fatalities in tropical systems occurs from that inland rain and flash flooding. Half of those in cars. So we still have work to do talking about automobile fatalities and flooding. It's all about the impacts. We spend so much time. We agonize over every one of those words when you look at those key messages, because people read those and they take actions. This is the last one. Gotcha 10. I don't know why I'm on this crusade, but I am. But there's no such thing as a fish storm. There's mariners. This is Lorenzo, right? 11 fatalities from a storm so far away from the United States. Look at this. We had 8 rip current deaths in the United States, including somebody very close to us in NOAA. There were 8 fatalities from that storm so far away. Please help me spread the word. There's no such thing as a fish storm. So far this year, as of 10/12/21, there have been 122 surf zone fatalities, most of those rip currents. So we have work to do. It's using science, it's using data to focus our messaging. That's it. So you can tell I could go on and on. I'm so humbled to even talk to everybody today. Humbled to be a part of NOAA. Definitely humbled to be around all these people that are much smarter than I am at the Hurricane Center. They're amazing. It really is all about those impacts. And I just want to reiterate, we can't do it alone. It really takes an effort, all of us coming together to save lives, and it's working, but we still have a lot of work to do. So that concludes it. Thank you, everybody.
Thanks so much, Ken. That was an excellent talk. Just as a reminder to everyone, you can type questions in the GoToWebinar question panel, and we'll get through as many as we possibly can in the remaining minutes here. We do have a few questions to start with. Ken, can you tell us what evidence there is for the greater frequency and increased magnitude of hurricanes over the past decades due to increases in ocean warming?
Okay, I'll answer it. And luckily, I got one of the biggest experts, Dr. Chris Lancy, behind me. So when I mess it up, he'll come over and push me out of the way. But here, one thing to think about when we think about, climate change and the tropics is the fact that you can't go by the number of storms. We have tools we never used to have. We have satellite. We have information that we're seeing things that we never used to see. So yeah, we ran out of names last year. We almost ran out of names this year. But that's not what we go by. So we are seeing some small evidence of, this rapid intensification. I can tell you that I'd like to see a study of the Gulf of Mexico with rapid intensification. I've seen more of those since 2017 than I've ever seen in my career. So there's some of that's going on. Sea level rise. We need to think about that in terms of storm surge. Two things. When you think of sea level rise, your first thought is higher storm surge, more, right? The other part is it's going to be further inland. It's going to be in places that never used to get this storm surge, could get storm surge in the future. And that's why we got to focus on looking at those vulnerabilities on the coast in places that never used to get it. Further inland is something that we need to look at. But the biggest correlation, and Chris throws something if I go wrong, the biggest correlation is your rainfall rates and your rainfall. That's a significant thing that we're seeing. The rainfall rates seem to be higher with a warmer atmosphere. You can also have a poleward, a northward progression of some of this tropical atmosphere, maybe more frequently, where you get those rainfall rates further north. We can get storms further north. I think that's something that we're going to have to look at. So I think we're doing a good job really looking at the storm surge fatalities and trying to prevent those. We need to really focus on also, really, we're doing it, right? The inland rain events, and really look at those rivers. We have the National Water Center, we have the Weather Prediction Center, and the weather forecast offices putting out those warnings. But we need a collaborative whole effort across NOAA to really look at those rainfall rates in places that are going to flood that have before. But it really goes to, what's the old saying? There's interesting, we give these talks, and the whole debate over, 1%, an area that has a 1% chance of flooding, these flood zones, and we have to get away from some of that terminology because people aren't perceiving that risk like they should. 1% just doesn't sound like much. 100-year flood, the public interpretation of that, well, I got it last year. I'm not gonna get it for another 100 years, right? So we have to watch this terminology because the reality is 1% chance is any given point every year, 100-year flood. Let's put it another way. That's about a 26% chance of having a flood in your 30-year mortgage. It's all the same thing, but only one of those is really going to prompt what we want in the way of preparedness and looking at flood insurance and that sort of thing. So we're going to have to look at our vocabulary. We're going to have to look at that as we go forward with a changing climate.
Thank you. So what kinds of data limit the precision of NOAA hurricane trajectory and intensity forecasting currently? What kinds of data would be useful in improving your models going forward?
Yeah, I think there's more to unlock in the ocean heat content. And we have information on how warm the water is, but it's, you look at a sensor that's on the surface, that's the water temperature at the surface, but what's really going on below the surface, that ocean heat content has so much to do with it. If you're stirring up cold water, you're stirring up warm water. That's one big factor. So that's one of them. The other part is with steering. I think we've done a great job. It's so important that we have the extra balloon releases. So anybody listening from the forecast offices, thank you. We've really looked at the aircraft data. We've looked at, thanks to EMC, looking at the modeling center. If you take that data out, and I know AOML is looking at some of this too, they can run the model with the data, run the model without the data. The data makes a difference. Okay, so that's helping. The other part here is we got to look at some of the resolution, because if you look at shear parameters. In other words, winds that are inhibitors to intensity. Are we looking at a 50-kilometer grid? Are we looking at a 10-kilometer grid? We got to figure out ways to be able to look at some of those parameters. What is that storm really feeling? Is it feeling some sort of average over a large area, or is it feeling something different? No shear, where you can get that rapid intensification, or there's some shear that we're not seeing. So there's other parameters when it comes to resolution, other measurement when it comes to the ocean heat content as well. There's a lot more going on here when it comes to the upper level winds and also when it comes to the ocean. So that data is just instrumental. Anything we could do, again, that WMO presentation yesterday, I didn't mean to have some sort of epiphany, but I did. But every leap in some sort of observational data led to a service improvement. And it was just a message that anybody listening that's in modeling and in observations, you're a big part of this. So those improvements are just going to be necessary as we go into the future. As we have more people along the coast, we have a changing climate. None of this is going away. Everything we do around NOAA, all the line offices, is just going to get more important than ever.
Thank you. So another question is that hurricanes look set to penetrate further inland as sea levels rise. How do we begin to prepare communities that are unused to thinking about hurricane dangers?
Yeah, it really, my opinion, it goes back to the beginning of my presentation. It goes back to those relationships. We've got to get in those communities. I just, my 27 years in the Weather Service, I can't emphasize enough in this presentation the value of those relationships. It's the trust. It's getting into those communities and saying, look, I'm going to sit through your exercise. This is maybe what's happened in the past, but let's look at what could be happening in the future and really push some of these communities to start looking at preparedness and their plans. 3 days, 3-day plans, 5-day plans, 7-day plans, whatever it may be, and really talk about, we've got so much expertise across NOAA, partnerships in FEMA, partnerships in the Corps of Engineers. How do we get together and talk about the resilience of these communities further inland from that heavy rainfall, from that storm surge that they never used to see? But now I'm a town 100 miles inland on a river. I never used to see this stuff. In the future, you may see storm surge wiggling up there all the way 100 miles in some of these river basins. We got to talk about it. This presentation was about tough conversations, real conversations, identifying the vulnerable. And I think we got to look at these vulnerable communities and go have those tough conversations in these communities. We got to get out of the office, out of our chairs, into these communities and really have honest conversations about the vulnerabilities and the threats now, but also going into the future. That's my opinion.
Thanks, Ken. On a related note, you mentioned earlier that some communities have struggle with interpreting 100-year storms. Have you considered different names for those kinds of storms? And do those models that actually designate a storm as a 100-year storm look set to change as the storms themselves just become more intense more frequently?
Yeah, we don't use the term. So we actually never try to use the term. We talk about the threat based on looking at the latest storm and the amounts and what those impacts could be, and really trying to get more into the inundation mapping and show exactly what these values are. We really stay away from those terms altogether, and that's why we have one of the social science projects that we have is called numeracy, and it really is looking at interpretations of things like 1%. If you have a 1% chance of hurricane force winds at day 5, that's a big chance. Doesn't sound like much though, right? So a 20% chance of rain here in Miami in the summertime, I don't bat an eye. Every day is 20, 30%. So looking at some of the data and how people interpret percentages, the numeracy of things, I'm really looking forward to getting some of that data and seeing how we can bend products, but we really try not to use those confusing terms. We really try to use terms in the heat of the battle with, this is what you're going to see. This is some of the record flooding you've seen in the past. If they can equate it to an event, people can really picture it. This is what I went through last time. And that's the social science part of this has to be in every conversation, because you go back, we actually talk about never compare storms. And the reason we do that, because the tendency you want to, just like this storm, the problem is if you're 10 miles away, you might experience something totally different. You go through a major hurricane, I lost my house, I had 10 feet of water, but 20 miles away, remember 20 miles, little wiggles matter? It wasn't that bad. The next time you have a big storm, if I'm that person that got nothing, I'm going to say I got through it last time, I'm going to get through it this time. They're not going to act. And a lot of those people have lost their lives. So we really try to avoid any confusing numerical type of thing, but also we actually try to avoid we actually try to combat comparing storms because we want the desired outcome. And that's why this whole 10% exceedance is going to be really important going into the future.
Thank you, Ken. We probably have time for just one or two more questions, so feel free to type those into the chat box and we'll get those answered for you. Another question is that, as you described, some of these communities have, again, struggled to interpret storms in relation to previous storms. Do you adjust your messaging at all when you're talking to communities that are more experienced with hurricanes versus communities that are less experienced?
Yeah, absolutely. And I think, you know, the Hurricane Center, and everybody, you know, listening knows we're aggressive when it comes to social media. We're very aggressive when it comes to media, television, radio, print, whatever it may be. We're very aggressive because if you look back to social science, right? I keep going back to that. A consistent message saves lives. If it's a different message, if it's inconsistent, a different value, people freeze up. They don't know which one to pick. So as a result, we really get aggressive with the media. What's interesting about it, this has been a trend. I think, is Dennis still here? This has been a big trend in the last 3 years, is we're getting more requests to do even local type media, and it's high level. The weather forecast offices, they have all the details of every nook and cranny. They're just amazing, in the river forecast centers. But at least we can go into these communities and say, hey, you know, this is what we think. You're 200 miles inland, but listen to me. I'm really worried about the rain because the Weather Prediction Center has you under a moderate risk. And this is what it means. So that ability to get into that market and say, hey, you're not used to this. We're going to back up a second. We're going to review some of these things a little bit more. These are some of your impacts, and this is what you need to do. It works. It really works. It creates a consistent message. And you have a different message than you would from somebody maybe on the coast that's more used to it, but you're worried about mountainous areas. You're worried about North Carolina. You're worried about Virginia. You're worried about Kentucky, where they're going to get a massive amount of tropical moisture, and you're worried about the terrain and flash flooding and mudslides. Virginia having just terrible mudslides. They had a mudslide in Ida, and they had significant mudslides back in Camille as well. Let's talk about that. I'm not going to talk about mudslides maybe for somewhere on most of the coastline, but I will when you start talking about inland, because that's what the weather forecast offices are really emphasizing. And we say, hey, stand by for those warnings, those river warnings. We start looking at those flash flood warnings, the flood warnings from the weather forecast offices. Have a weather radio, have your phone ready, have these things ready to go. You change the message based on the threat, and it works. Again, having the honest conversations, even the parameters, the gotchas. I've talked about these gotchas in the media during a storm, saying, hey, don't be caught with the generators. Please, a hurricane's not the time to learn how to use a chainsaw. Tough conversations, but they're absolutely real, and they have to take place. That's how you save lives.
Thanks so much. I think we're going to wrap it up there. So with that, I will just say thank you again, Ken, for a really terrific talk. And thank you to everyone for joining us today. Our next NOAA Environmental Leadership Seminar will be December 2nd, and our speaker will be Dr. Richard Spinrad, Undersecretary of Commerce for Oceans and Atmosphere and NOAA Administrator. We hope you will join us. Goodbye.